Hello students, welcome to the new lecture session. Myself Shankar Ghosh, Assistant Professor of Automobile Engineering Department at Dr. Sudhir Chandra Sood Degree Engineering College under the JIS group. Today we'll discuss a new topic, that is application. This topic is taken from the module number 11 in name of Common Application of NDT. This topic is also again collected from the subject of non-destructive testing and application. And this subject is the 7th semester automobile engineering students subject. And the subject code is AUE 705A. So students, this lecture session on this of application of NDT, we understand about the application, and there are various kind of NDT methods according to the application nature এবং application nature. So student, let's start the today's class on application. And this application start with this start with what is NDT. In the previous lecture we all discussed about the NDT, these various types, their advantage, disadvantage, application, and all these things. And now in this class, before starting the common application, starting the common application of NDT. So let's discuss about revise the definition of the NDT. So students, what is NDT? The field of non-destructive testing. The field of non-destructive testing, NDT, is a very broad interdisciplinary field that plays a critical role in assuring that structural components and systems perform their function in a reliable and cost-effective fashion. So, the field of NDT is a very broad. So the field of NDT is a very broad interdisciplinary field that play a critical role in assuring that structural components and the systems which performs their function in a reliable and cost-effective fashion. The NDT techniques and engineers define the implement. The NDT techniques and the engineers define the implement tests that locate and characterize the material conditions and flaws that might otherwise cause planes to crash, reactor to fail, trains to derail, pipelines to burst, and a variety of less visible but quality traveling events. These tests are performed in a manner that does not affect the future usefulness of the object or the material. In other words, the NDT allow parts and the material to be inspected and measured without damaging them. Without damaging them, because it allows inspection because it allows inspection without interfering without interfering with a product's final use the entity provides an excellent balance in between the quality control and the cost effectiveness. So this entity allow the inspection without. So students, this entity, the non-destructive testing is allow. Testing allows inspection without interfering with a product's final. Where entity provides an excellent balance between quality control and the cost effectiveness. Generally speaking, the entity apply to the industrial inspection. Generally speaking, the entity apply to the industrial inspection. The technology that are used in NDT are similar. The technology that are used in NDT, are similar to those used in the medical industry, but non-living objects are the subjects of the inspection. Next is, what is NDE? NDE stands for non-destructive evaluation. That is NDE. This NDE is a term. That is often used interchangeably with the NDT. However, technically the NDE, or the non-destructive evaluation, is used to describe the measurements that are more quantitative in nature. For an example, an NDE method would not only locate a defect. An NDE method wouldn't only locate a defect, but it could also be used to measure something about that defect, such as its size, shape, and the orientation. So, for an example, this NDE method would not only locate a defect. The NDT method wouldn't only locate a defect, but it would also be used to measure something about that defect, such as its size, shape, and orientation also. The NDE may be used to determine the material properties, such as fracture, toughness, formability, and the other physical characteristics. So basically find out the size, shape, and the orientation of a material. The NDE test is used to determine the material properties also, such as the fracture toughness, formability, and the other physical characteristics. Now, coming to the application of the NDE. The NDT or non-destructive steel is used in everywhere. It's mainly in the production purpose or the maintenance purpose. The NDT is a most important, memory takes an important role, and the application is that here we discuss a few points of application, that is rail inspection. Sorry, that is number one is rail inspection, number two liberty bell inspection, number three where rope inspection, number four is tank inspection, number five pipeline inspection, number six bridge inspection, and number seven is aerospace industry inspection. So as I told, NDT is used in everywhere. That means in the production purpose, maintenance, or servicing field. The NDT is mostly used. So among them we discuss here a few points. So students, let's start with this rail inspection. So today in this class we'll discuss only this rail inspection. So rail inspection, what is this rail inspection? One of the major problem, one of the major problems that railroads have faced, the railroad have faced since the earliest days, in the prevention of service failure, is the prevention of service failure in track. One of the major problems that railroad have faced since the earliest days is the sorry, is the prevention of service failure in track, as is in this case in the case with all modes of high speed travel, and or the case this case all modes of high speed travel, failure of an failure of an essential component the failure of an essential component can have serious consequences can have an serious consequence. The North American Railroad have the North American Railroad have been inspected their most costly infrastructure assets. The North American Railroad. The North American Railroad have been inspecting their most costly infrastructure asset, the rail, since the late of 1920s. With increased traffic at higher speed, with increased traffic at the higher speed, and with the heavier axle loads in the 1990s, the rail inspection is more important. The rail inspection is more important today than it has ever been. Although the focus of the inspection seems although the focus of the inspection seems like a fairly well-defined piece of steel. The testing variables present are significant and make the inspection process challenging. The rail is manufactured in different way. The rail is manufactured in different ways. There are different rail conditions. That means wear, corrosion, etc. were present. There are a significant number of potential. There are a significant number of potential defects possible, and the task has to be performed with some speed to reliably inspect the thousands of miles of track stretching across the land. Stretching across the land. Sperry Rail Service, one of the country's leading inspector of railroad tracks, that has been using specialized that the equipment mounted on self-propelled rail cars. The specialization test equipment mounted on self-propelled rail cars for over 70 years to protect the safety. 70 years to protect the safety of passenger and the freights. And this information provides a brief look at the rail inspection. The history of railroading is rooted. The history of railroading is rooted in the production of the first metal rail. Near the city of Sheffield, England, in the year of 1776. So the history of the railroading is rooted in the production of the first metal rail near the city of Sheffield, which is stayed in England, in the year of 1776. The rail improved the transportation of materials in industries such as mining. At the starting of this, in the year of 1803, the first railroad intended for the public use was opened for the operation in between the London Dock and Croydon. So, in the year of 1776, the railroad is routed for the mining purpose. That means especially for the transportation purpose. And from the year of the 1803, it is started for the public transportation from London Dock to the Croydon. This first railway, the Surrey Iron Railway, offered a smoother ride than a wagon. And the first railway, the Surrey Iron Railway, offered a smoother ride than a wagon, but it offered no real advantage in speed since the draft animals were used for the locomotion. However, The first steam locomotive was soon to arrive on the scene in the year of 1804. That means after starting the public transportation, son, after the next year of starting the public transportation through the train in the year 1804, a steam locomotive pulled a train. A steam locomotive pulled a train of cars carrying several tons of ore for the iron work at Methyl Titlefield in South Wales. And the first American locomotive, the first American locomotive, the best friend of the first American locomotive, the best friends of Charleston, was placed in operation on the South Carolina Railroad, Railroad in the year of 1831. And this is the picture of the various type of design of railroad, the cross-sectional view of the railroad. In the year of 1767, the cast iron plate is used. Then that is the 5 feet long. Then in the year of 1776 to 1793, in between, the cast iron rail is used, but that is 3 feet long. In the year of 1799, that time these types of in the year of 1789, in these two types of cross-sectional view of the rail track is used, which is made from the cast iron edged roll and then this is happens in 1789. In the year of 1797, these types of cross-sectional view the rail track is used, which is made from the cast iron edged roll. 1802 in this type, 1808 this is the type. 1808 to 1811, in between this there is that time used this type of plate, that is Miller iron rail. 1820 it looks like this. It changes from the 1860, and then it come into next is 1830. 1831 it was slightly changed. 1831 it is modified. 1835 it should be modified in the U shape. In the 1837 it was a lock rail shape. 1844 it was U shape also. 1844 it will be shaped a new design, and 1845 it is modified. 1858 it is also a modified version. 64 is modified. 65 it is modified. 76 is also modified. 1900 is also modified. 1916 is modified. 1930 it is modified, and in the year of 1946, cross-sectional view looks like this, which is used in nowadays in a rail track cross-section. The rails have evolved from cast iron plates to special alloy steel. The cast iron plate to specially alloy steel, which are rolled on a standard shape and specially heat treated to obtain the desired properties. Properties. In present day, steel rays are vastly superior to their sorry. In the present day, steel rays are vastly superior to their predecessors in both strength and the wear qualities. However, defect still developed. However, the steel defect still developed. The heavy load and the high speed of today's train can cause rail to fail in service unless regular inspection are performed and regular inspections are performed were initially performed slowly by the visual means. Of course, visual inspection will only detect the external defects and sometimes the subtle signs of large internal problem. The need for a better inspection method became a high priority because of a derailment at Manchester, New York in the year of 1911, in which 29 people were killed and 60 seriously injured. In the US Bureau of Safety's, now the National Transportation Safety Board, investigation of the accident, a broken rail was determined to be the cause of the derailment. The Bureau established that the rail failure was caused by a defect that was entirely internal and probably could not have been detected by the visual means. The defect was called a transverse fissure. The railroads began the investigation and prevalence of this defect and found the transverse fissures were widespread. In the year of 1915, the Bureau of Standards began research to determine if magnetic testing could be used to detect transverse fissure. The inspection technique involved the passing a magnetizing solenoid along the rail to establish a flux in the rail. The flux leakage caused by a defect was detected with search coil. The technique was successful in the laboratory, but was unable to differentiate between the defects and non-relevant failure features in the field. In 1923, Dr. Elmer Spady started to develop and build a rail inspection car with the capability of detecting the transverse fissures in railroad rail. In 1927, Sperry built an inspection car under the contract with the American Railway Association. Here is the picture of the rail inspection car. The small flatbed in the front of the cab, contained the inspection equipment. The operator and the recording device were housed in the cab. In the year of 1928, a Sperry built an inspection car that is SRS 102 was
testing rail on the Wash Wabash railway at Montpelier, Ohio. The inspection techniques Spire used established a strong magnetic field in the rail by passing a large amount of low voltage current, amount of low voltage current through it. A pair of such coils fixed at a constant distance from the rail and detected any changes in the magnetic field around the rail. This magnetic induction flux leakage technique became the foundation of early rail inspection. Unfortunately, the transverse fissures were not the only type of defect found in the rail. Other manufacturing and the service related defects that can be occurred, including inclusion, seams, sealing, and the corrosion also. The fatigue cracks can initiate from this defect as well as the normal features as well as the normal features of the rail such as bolt, holes, etc. If these defects go undetected, then they can lead to rail head and web separation. Many of these defects are not detectable with the flux leakage method because the flow run parallel to the magnet flux lines, or the lines or the flows are too far away from the sensing coils to detect it. The induction techniques inspect mainly the railhead. To complete the flux leakage method, and detect the additional flow types, ultrasonic inspection was become common. High frequency sound is transmitted into the metal rail. Through the metal rail, and reflection from rail joint and surface condition, reflections from rail joints and surface condition, as well as the internal defects are displayed on a screen or cause movement of a pen on a recording tape. Both normal and the angle beam techniques, both the techniques are used here, as the both Persico and the pitch catch techniques. The different transducer arrangements offer different inspection capability. Manual contact testing. The manual contact testing is done to evaluate small section of rail, but the ultrasonic inspection has been automated to allow the inspection of large amount of rail, like the electromagnetic techniques, which is already discussed earlier. The first all ultrasonic inspection car was introduced in the year of 1959, and this car was developed specially to meet the needs of the New York City Transit Authority, NYCTA, which means the New York City Transit Authority. Next, the high rail tracks currently used only the ultrasonic because the electromagnetic equipment is too large for this vehicle. The detector car will test rail in between 6.5 to 13 miles per hour. However, higher speed units are in development. Here is the picture of a high rail. And after detected, the data from the inspection equipment is fed to the operator inside the car, and Federal Railroad Administration or FRA rules require that any indication considered suspect by the test equipment on the test car are hand different equivalent immediately, and this leads to a stop start test mode. When the operator sees something on the tape indication a problem, and he uses a buzzer signal system to tell the driver up front to stop, and the car then bucks up to the point of examination where the operator get out to hand test the rail with an ultrasonic test set mounted on the rear of the car. If a defect is confirmed, it is marked, and a railroad work crew following the spare car will change the rail. If they cannot get to it right away, the section of track is assigned a slow order until the crew can repair it. And the amount of rail being tested can be increased by the use of chase car, which is following the testing vehicle. The chase cars will receive a radioed signal of the test being done by the lead truck and will stop to do the necessary hand testing, and this elimination of the need to back up to the hand test, and it allows the testing vehicle to move forward continuously testing, with the result being sent and recorded the maximum examination by the chase car. So class, here we discuss the rail inspection, and the other inspection we will discuss on the next class. Till then, stay at home and stay safe. Thank you so much, students.